course, there's more shifts than that. We also have, we just talked about shifts up and down. Whenever there's a number inside the absolute value, we get different kinds of shifts. And since the other two were outside, they moved up and down. The ones inside, I'm sure you can guess, they move it left to right. Okay? But let's double check here real quick. I'm not going to do a chart, but we're going to go through the numbers real quick. And I'm just going to pick, I'm going to start with negative 2. Okay, so if I plug in negative 2 for x, I get negative 2 plus 2 is 0. So at negative 2, I know that I'm at 0. What if I plugged in negative 1? Well, negative 1 plus 2 is positive 1. The absolute value of positive 1 is 1. And let's try 0. 0 plus 2 is 2. Absolute value of 2 is 2. Looks like we're going in one direction. Let's try 1. 1 plus 2 is 3. We haven't seen the numbers kind of bounce back the way absolute values do, so maybe I need to go this way more. Let's see what happens. Negative 3. Negative 3 plus 2, well, that's negative 1. The absolute value of negative 1 is 1. Uh-oh, looks like I'm bouncing back now. So I'm guessing that negative 4 plus 2, that's positive 2. I'm sorry. Negative 4 plus 2 is negative 2, but the absolute value of negative 2 is positive 2. So you can see there's my absolute value. It bounced back. And what happened? From my parent graph, I've shifted this way. But it's the opposite of what the outside numbers do. So when it was positive, it shifted up. When it was negative, it shifted down. Now it's a positive number, and instead of shifting positive on the x-axis, it shifted negative on the x-axis. Okay? So whenever it's positive, that means we are going to make a shift left, which means that if we do a negative, that means we should shift right, correct? Let's double check. And this one's actually, example number 4 is a little bit harder because I put a negative on the outside. This is a different kind of shift or a different kind of translation. So let's take a look at this. So if I plug in, what I said was this shifts it left, this should shift it right. So if I wanted to find the point where it bounces back, it would probably be positive 2. 2 minus 2 is 0. Absolute value of 0 is 0. Negative 0, there is no such thing, so we have 0. And that's when x equals 2. What if x equals 1? Let's go this way, 1. 1 minus 2 is negative 1. The absolute value is 1. But then we have a minus on the outside, so it becomes negative 1. So now we see it going down a little bit. Let's try 3. 3 minus 2 is 1. Absolute value of 1 is 1. Negative 1 with the negative applied to it. Okay, let's try 0. 0 minus 2 is negative 2. We get positive 2 with the absolute value, but then we get the negative 2. So at 0, I have negative 2. What about, let's see, 1, 2, 3, we didn't do 4. 4 minus 2 is 2. Absolute value of 2 is 2. Then apply the negative, we get negative 2. So you can see with these points, we just did 2 shifts. Because this was negative, we shifted this way 2 units. But the negative outside made it also flip down. So in this case, we had 2 translations. We have the negative and the negative 2. So again, the negative 2 moved it this way 2 units. The negative outside the absolute value flipped it down. So the graphs that you're going to do for homework are just like this. We might double up the translations. So you might have more than just one shift vertically or horizontally. You might have both, in which case your graph's going to look a little bit different than the parent graph. But the slope pretty much, or the V, should look pretty similar. Okay?